Hey everyone, we talked about the electric potential a lot and its relation to the electric potential energy. We never talked about its unit in a specific way. We said that the electric potential here that we learned about from before, there's the electric potential. We said the electric potential V is equal to the electric potential energy divided by the test charge Q. Okay, we said, this is in joules and this is in coulombs, so the units should be what? Joules per coulomb, but we never gave the joules per coulomb its own unit or derived unit basically. So this is the voltage or the voltage difference. So for instead of using every time joules per coulomb, we wanted to give it a specific name. We called it volts. So this is volts. And you know who Volt is. He's a scientist who studied electricity a lot. So in his honor, we're going to give this unit to him, and short for V. So V is measured in V, basically. Okay? So that's the unit of the electric potential. Now, what is V is actually the battery. It's what you go to the store and buy, okay? You buy what? The battery. The battery looks like this. This is positive side, and this is negative. As you can see, the battery is polar, which means that it has a positive side and a negative side. And if you look carefully at it, you would see that this type of battery, the round one, is 1.5 volts. Whether it is AAA, AA, or C's or D's, all of them are what? Actually, they are all 1.5 volts, okay, each one of them, all right? So that's what you pay your money for. You pay money for electric potential. Now, another unit that we need to pay attention to is known as the electron volt. The electron volt. And what is the electron volt? It is said that the electron volt is used to measure energy for small charged particles like electrons, protons, the alpha particle. All of these, when they are moving around, they are carrying energy of them. And this energy is so small, you cannot use joules for it, because that will be actually not, it's like you're measuring the distance between here and the stars using centimeters. Okay? So that's not going to work. So these objects are very small, and joule is a very big unit compared to these objects. So you need to use a very small unit appropriate for measuring these small particles' energies. Okay? And there's another definition similar to this one. Electron is defined as the work required to accelerate an electron through a potential difference of 1 joule per coulomb. And the joule per coulomb here, we acknowledge it is the volts. Okay? All right, do you remember this equation? Q times V. So when you accelerate an electron, Q times V, it attains or acquires a kinetic energy that is equal 1/2 mv squared, where this V here is the velocity, not like V here is the voltage. Okay, that's known as the kinetic energy. So basically, that's what happens if you accelerate an electron from rest. So here the electron is at rest, and you accelerate it through 1 volt difference, and it attains here a kinetic energy that is equal to 1/2 mv squared. All right. So the charge is the electron. So I'm going to plug in the numbers here. The charge is the electron 1.6 times 10 to minus 19 coulomb, and the voltage is 1, so 1 volt, so coulomb volt, right? And that should be equal to the kinetic energy. So kinetic energy is energy. Is coulomb volt, this is coulomb, right? Is coulomb times 1 volt energy. See, coulomb times volt, take it all the way here, that's a volt, and that's joule. So volt is equal to joule per coulomb. So multiply by Coulomb, multiply by Coulomb, Coulomb with Coulomb cancels. So Coulomb volt is actually Joule. Yes, Coulomb volt is actually Joule. So this here, the kinetic energy, which is basically gained by accelerated electron through a potential difference of 1 volt, is a measure of energy. So this here whole thing is known as the electron volt. And notice how I write it. E is small, V is big. Okay, so 1 electron volt is equal to 1.6 times 10 to minus 19 joule. So that's a definition for an electron volt. If I were you, I would remember this unit very well because it's very important to know. Okay. And for example, other examples you may see, for example, an alpha particle is traveling with this energy, which is sometimes they put it as 6 mega electron volt. It's kind of like a compound unit or indexes of units. So this is equal to 6 times 10 to the power 6, because mega is 10 to the power 6 electron volt. There it is. Okay? And that's it for now. Thank you.